Hi, Julian here from PopcornFX. In this video we are going to see how to create a simple rain effect by reusing the dust effect we created in the previous videos. So first I will clone this dust effect by hitting Ctrl F2 and naming it Simple Rain. So here is our dust effect, and to make rain from this, well, this is basically the simple rig that wraps around the camera, has speed lines, and handles the pre-warm that we saw in the previous videos. So to make rain out of this, the first intuition might be to just go inside the behavior, which I'll rename rain behavior, and select the physics node and set a gravity, because after all, rain falls because there's gravity. And indeed we have something that kind of looks like rain. The particles are falling down. That's good. By the way, I've set up this project differently from the default PopcornFX project. Here I have a Z up coordinate system, because the goal of this series is to bring these effects inside Unreal, and Unreal has a Z up axis system. So I've set up the project to be Z up. Just a small parenthesis. So you can notice there is something a little weird here. We have some very long range streaks and very short range streaks, and this is very visible if I disable the life fade, where the particles fade when they are born and fade out when they die. If I disconnect this, here you see very clearly what's happening. Basically, when the particles spawn, they have no initial velocity, so they just pop in midair and then progressively start falling down. And as the particles reach the bottom of our view space cube and wrap back up, their velocity when they wrap back up is the velocity they had when they're down, and so it means that they have already a high velocity and they keep on accelerating and wrapping and accelerating again, etc. So their velocity always increases until the particle dies. So this makes an effect where we have very, very different velocities, and this is not how rain actually works. So just a quick look at a reference video here. You can see that the rain in the background, even though it's kind of blurred, you can see that the rain in the background has more or less the same velocity, constant velocity, and we see the raindrops falling from the leaves, and these start at a zero velocity and progressively accelerate. So having the particles starting without a velocity would be fine for falling raindrops, say from roofs or in-game geometry in your level. But for the particles that are kind of the filler rain, that fill the empty space, this is the rain that falls from a high altitude, from clouds, and this rain is actually at a terminal velocity, so all the raindrops more or less have the same velocity, so we can't really use acceleration here or gravity. We could use that, but by setting up the drag and the initial velocity to kind of match, but that's a bit overkill for this effect. We'll be much better off using a constant velocity. So here let's say minus 4 meters per second. So waiting for all the particles to respawn, and now we have falling rain without artifacts at a constant speed, which would be the terminal velocity. So to have a better idea of actual terminal velocities of raindrops, searching raindrop speed versus size gave me this as a first result. And this website gives some ideas about the size of a raindrop and its terminal velocity. So this can go from below 1 meter per second for very small raindrops, which are between 0.2 and 0.5 millimeters in diameter, up to 9 meters per second for larger drops, around 4 to 5 millimeters in diameter. And they also say that in some cases, like very, very heavy rains, you can go up to 13 meters per second or so. And there is also a video linked on that site with a very interesting animation. It's a video from NASA. And this shows that the actual shape of raindrops isn't what we usually picture as being raindrops. So it's not a tear-shaped drop. It's actually a ball, and when it grows, due to air resistance, it will flatten and become more like a pancake. And when the drops get big enough, so usually above 5 millimeters, they, due to air resistance, they split into smaller drops. So this also gives us kind of an upper bound to what size can the raindrop have, and therefore what top velocity it can have. So this gives us a rough ballpark of what we can expect as sizes and speeds for raindrops. So what I'd like to do for this effect is add a new attribute to the effect interface so that I can, from the game engine, change how heavy the rain is. I want to be able to change in-game if it's a light rain, a heavy rain, without having to make multiple effects for each type of rain, and actually have a smooth transition. So here I will create a new attribute directly from the effect interface of type float, so it's a single scalar value, and I will name this rain seriousness, how serious the rain is. I will say it's a slider and it has a min of 0 and a max of 1 and a default value of, let's say, 0.5, so that's a half serious rain. So now I'll drag and drop this inside my graph, and from this I can do a lerp between two speeds. So when the rain is not serious, I'll take the lower bound and say that they go at, let's say, 1 meter per second, and when the rain is very, very serious, they will go at 9 meters per second. So now, instead of specifying the velocity directly inside the physics, I will just clear that. Here I will compute the velocity by multiplying the scene up axis, and actually the negative up axis, because I want the particles to fall down, multiplied by the speed, and this will give me the initial velocity. So this is as it is the initial velocity, this is evaluated at spawn, and I have to wait for new particles to spawn to see the velocity change. This won't accelerate a slow-moving particle when I change the slider, and similarly the particles that were falling down quickly will not slow down. So here I have my not very serious rain and very serious rain here, which falls much faster. So I can also use that to change the actual size of the raindrops. So I will use another lerp node. So from that website we saw, they were saying that for a raindrop going at around 1 meter per second, a good size would be half a millimeter, and for one going at 9, it would be around 8 millimeters, or maybe a bit less, I don't exactly remember, maybe 6 or 5. Yeah, 5. Let's say 8 or 7, because we still want to be able to clearly view them, so we're not totally physically correct here, but we're faking things in real-time VFX anyway. So this is the diameter, and for rendering and to wire that into my billboard and into my script here that computes the fading, the stretch-based fading, I actually want this to be the radius. So here I will divide that by 2 to get the radius from the diameter, and I will wire that in here. And here, because my texture is actually not taking up the entire space, it's only about half of it, this will actually appear much smaller than it should. And here I can't see anything, or very barely. So I will have to remultiply that to compensate for the fact that the actual dot in the texture is smaller than the geometry of the billboard, of the sprite. So I was going to multiply back by 2, which would make this one pointless. I could just directly wire this in. But I kind of prefer separating the logical steps here, because then I can pull that out and know that this is the value going out here is the actual physical size, and then I can have the artistic side of things, the artistic tweaking happen here from the actual physical size. I find this much easier to tweak and control afterwards, rather than having some magic numbers where you're not really sure what they mean, and where you can actually break effects by tweaking things you don't understand. So here I'll name that raindrop radius, and this is the raindrop speed. Right, so I'll quickly make this slightly brighter so it's more visible in the video, and we better see the rain. And now if I take the seriousness of the rain down, we should have much smaller raindrops that go slower. And here you can actually see that we are back to the issue we had with the dust motes effect, this being that we still have 25,000 particles, but here we see almost none of them because they are so small. So one thing we can do instead is I will bump the minimal size to actually 2 millimeters, so we see it a bit better. The falling speed is still what it should be, and I can actually also decrease the spawn rate by changing this dust property nodes, which I will name rain properties. So I can actually change the spawn count here by using the rain seriousness with a lerp node, and instead of just outputting the spawn count value here, which I will also rename to raindrop count, and raindrop lifespan. Right. So instead of directly wiring this out, I will take the rain seriousness, lerp between, let's say, 0.1 and 1, and multiply the raindrop count by this value. And now I only have 5,000 particles when the rain isn't serious, and even less, 2,000 when it's really not serious. slow falling raindrops, and when it's very serious, I'm back at the full force 25,000 rain particles. One last detail here: when I bring the rain seriousness all the way back to 0, I will actually want to stop any rain from falling. This will allow in the game engine to basically have this effect running, always running, and just set the rain seriousness to 0 to have no rain. So to do that, I don't really want to lerp between 0 and 1, because it would mean that here I'd have a ridiculous amount of rain particles. I'd have maybe, when it's very small, I'd have like 1 drop every 2 or 3 seconds or something like that. I don't want that. I want a hard stop. So I want it to go, let's say, from 5,000 to 500 just before 0, and if it's exactly 0, I just want it to cut all emissions. So to do that, I will take the rain seriousness value and say, is it greater than 0? So when I have nothing wired in a pin, it's 0 by default. So is it greater than 0? And if it is greater than 0, I will use the value of my lerp node here. And if it's not greater than 0, so if it's equal to 0 or lower, I will just use 0 as the output. So now, here I still have 2000 something. Even when I set a very small value, I still have particles, but when I set exactly 0, now all emissions stop, and I'm back to no rain particles. I still have 1 particle, but as I said in the previous videos, this is this event multiplier node, which is still alive. There is 1 instance of it which is listening for the changes in case I bump the rain seriousness back up, because I set its life to being infinite. Just a quick word here about the sliders. In case you haven't seen that you don't have to change the slider values by clicking on it, it can sometimes be pretty hard to tweak or to set to a specific value. You can right-click on the slider and it will pop an editable input box where you can type exactly the value you want. That's it for this video. I hope you liked it, and stay tuned for the next ones, where we will see how to add collisions to the rain particles and how to use LOD for the effect to be cheaper, and in upcoming videos how to do multi-layered rain effects for even more LOD goodness. Thanks for watching.